Okay, so let's talk a little bit about how to sort of reverse the list, right? So I mentioned, well, not reverse. So that's what I got hung up on yesterday, and so basically the order of points is being read 0, 1, 2, 3, 4, and then all the way up this list. And that's how you get this interesting pattern, because then it reverts back to 11 here, and then 12, the second point in that list, is now the first index value that we've generated. And I think it's called flip matrix. Yeah, that's it. So the tool that we would want to change the way that this list is being read is called flip matrix. So if you double click, and I'm double clicking because I forget where it is because I don't use it that often. So flip matrix is the one that you're looking for. And this is also a good time to take a quick sidebar again and show you another very nifty tool. So if you, like me just now, need to find a tool, you kind of know what it's called, and so you have to search for it, but you don't know where it came from. You might then wonder, where did it come from? Right? What tool menu does it live in? So if you hold, is it Control and Shift? No, Control Alt. Yeah. So if you hold Control and Alt, notice how this little blue I button shows up. I think that's short for information. I'm guessing. It should be short for information. But anyway, if you click on that particular item, it shows you the tab that it's under, and it also pulls open the panel that it lives in. So if you go under Set and Tree, that's where you're going to find Flip Matrix right here. So I know that it's a function of a tree, which means it's the way that the information is organized and structured. Okay, so anyway, flip matrix. What it's going to do is it's going to swap your rows and your columns. So data as a tree. I think it's going to be on the points. So I'm pretty sure this is going to replace the connection between the points, and it'll just flip the organization of those points. So if I put it in from the points, and then I override the connection to the base plane of the circles, that didn't do it. Does that have to be flattened? Yeah. No. Hang on. Why did that group it? Maybe it's the data I have to flip. That doesn't make sense either. Rows and columns, flipped data matrix. Maybe. All right, so this makes me think. What I'm getting is this kind of error. Let me just try something. I'm going to think through what I'm seeing here. This error is basically telling me that I have circular logic, right? So I have something that I'm trying to map in one particular way. Looks like it's getting mapped exactly the same way many times over. So that's why you see every single radius in the same instance, I think. And I think that's because the matrix is dependent upon a grafted tree. Now, graft is a new term. A grafted tree is one that has branches. So it's basically the same thing as something that's unflattened, if that makes sense. So what I think has to be done is I think the points have to be unflattened. And then it needs to be flipped and then flattened on the output, if that makes any sense. So let's try that. I'm going to unflatten this. And so you see that now my point connection to the flip is grafted, right? So I'm going to start using that term now. See these dotted lines? Those are grafted into sets. And now it's also grafted into the length. And so it's giving me an incorrect read, right? Because it's reading 7 locally defined values. That's not what I want. What I want is to now flatten on the input side of the list. So if I flatten on the input, that means that I'm still getting those 77 values, or what used to be 54, I'm still getting 77 values, and so my output is still going to read 77. So it doesn't matter whether or not you flatten it on the output or the input. You just need to know, abstractly it doesn't matter. But in some cases, you're going to need to pull it apart and do it a different way. So anyway, this gives us the ability to put a grafted list into the flip matrix. And then we would take that list and then re-flatten it on the other side. Okay, so if I re-flatten it here, now you see the order is going the opposite direction. So I have 0, 0, 0s, and then 1s, 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 2s, 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 so on and so forth. 77, 77. Why are they still reading in that order? Shouldn't be reading those numbers. Oh, that's why, because this is, there you go. I'll have to flatten this one as well, and then it'll read properly. Okay, so how confusing was that to you?
Very.
Raise your hand if it was more confusing than a level 5 out of 10. Okay. So anyway, let me talk through it again. I'm just going to try and clarify this in the best way possible. Actually, this is probably the best way.
Okay, when
Yeah.
you did the flip matrix?
Yeah.
Yours says D. Or...
D? Yeah.
Mine says M.
You probably flipped M or N?
M.
Then it's probably mesh flip that you selected. That. Yeah. Okay. So let me go back here for a second. And the important part here is going to be this. So I'm going to copy and paste and pull it down and turn this stuff off. Okay. So let's look at this in an abstract fashion. We have a grid. Okay. That grid is made up of numbers. These numbers are reading. So this is your point output. No flattening. Nothing has been flattened. Let's take a look at the param viewer, just to give us some extra visibility. See, that's coming out in branches. Branches. What's happening here really is a function of whether or not you want to flatten it at a certain point. Okay, so what I did was I flattened here originally to create my linear pattern that was going at the diagonals and everything, because I wanted it to go 0, 1, 2, 3, 4, 5, and I wanted to go, through an entire list with my pattern. But flip matrix has to flip rows and columns. If it doesn't have a designation for a row and a column, it can't flip it. So what's happening here is that this data is all being read as an individual row and column, I think. Something like that. So now your param viewer is showing an individual instance for every single one of those being flipped. And so now you have 77 different items that are all passed out into individual little groups or sets, right? Individual branches. And so when you plug that in, that's why you had all of those circles in one space, because that pattern is being repeated 77 times throughout the entire sequence. Does that make sense? So what it should look like is you have to leave it unflattened, right? So grafted is the other way of describing that. Leave it as a tree with branches. Let it flip the rows and columns. Then, when you flatten it, it's going to read as that one singular list as it goes through. Was that more clear? Seeing it that way? And then the other visibility thing that I can do to help fix that up is just replace those points here. So now you see 0, 1, 2, 3, 4, 5, 6 is now going in the x direction instead of the y. Still above a 5? Below a 5? All right. Well, I take your silence as I kind of get it. All right. So anyway, going back to the original thing. Allow the flip matrix to flip your rows and columns before you flatten it into a singular linear list. And that will get you the opposite direction. Okay, so now if we change the y, it won't change the pattern. And if we change the x, it will. Okay? So actually, I'm going to kind of isolate that whole conversation about that into one video before I move on to some of the other stuff, if you don't have any other questions.